All right, so average rate of change, this is basically just slope. We're just finding slopes, okay? So let's start with a slope review because you guys have done slopes before. So remember, slope is rise over run. So it's how far up versus how far over you go. Okay, so rise over run. Let's look at example A. So we have these 2 points there. We need to see how far up we go and how far over we go. So we go up 3. So we rise 3. And then we go over to the right 4. So we run 4. So the slope there is 3 over 4. And M just always stands for slope. Okay, let's look at B. So here, we rise, however many that is, 8. We rise 8, and then we go backwards 4. So we run back 4. So this is going to be 8 over negative 4, which is going to be negative 2. So if you notice, it's kind of like thinking about if you're walking uphill, that's a positive slope. If you're walking downhill, that's a negative slope. Okay? And let's look at C. So on this one, we're walking a straight line. And it doesn't rise at all. And it runs like 6 or 7, I don't know. 7, maybe. It runs 7. But our slope here is 0 over 7, which is 0 still. Okay, so that's a 0 slope. That means there's no slope there at all. That's just flat ground. Okay, so if it's positive, you're walking uphill. Negative, you're walking downhill. And it's 0 if you're just walking straight. Okay? And then let's find this using points now. So M is always y1 minus y2 over x1 minus x2. Which is basically the same thing that we just did up top. So I'm just going to label these x1, y1, x2, y2. So that's going to be 3 minus negative 7 over negative 9 minus negative 5. When you subtract a negative, it becomes a positive. So that's 3 plus 7 over negative 9 plus 5, which is 10 over negative 4, which is negative 5 halves. So the slope there is negative 5 halves. Okay? Let's do E. So we're going to label x and y, put it into our thing. So negative 1 minus negative 4 and 2 minus negative 7. Go through and simplify this. You end up with 1/3. Okay. Last little example here. So x1, y1, x2, y2. So y1, negative 5 minus y2, so minus 3, over x1, negative 3 minus negative 1. That becomes negative 5 minus 3 over negative 13 plus 1. Simplify that down. A negative divided by negative is a positive, so they can go away. Reduce that, you get 2/3. Okay, pretty simple, pretty straightforward. Let's look at this. So this is where we're going to get into this. So we are graphing all these different functions now. And sometimes they just want to know the average rate of change between 2 points on that function. So like over to the right, we have this parabola here, this upside down parabola. Say they wanted to know the average rate of change between those 2 points. You can draw a line through that, and that line is called a secant line. So the line that crosses through the 2 points is called a secant line. Okay? And that's just going to find the slope of those lines. So we can read this. The average rate of change of a function between 2 points is, that should say slope, not slop. The slope of the line that passes through these points. And that's called the secant line, like I just said. Okay? And then the formula for this is pretty much the same as it was for finding regular slope. So it's f of b, which would be a y-coordinate, minus f of a, which is also a y-coordinate, over b minus a, which are x-coordinates. Okay? So let's just get into this. So given the function below, find the average rate of change on each interval. And it's always a, b. The first one's a, second one's b. Just make it simple. Okay, so again, that formula is f of b minus f of a all over b minus a. So we need to find f of 1, because that's b, f of negative 2, because that's a, and then the bottom we'll just simplify. So let's find f of 1. The way I'm going to do that is I'm going to draw a line right through 1. Okay, that's where x equals 1, so I'm going to draw a line right through there. And I'm going to see, where does that cross this parabola? It crosses it right there. And that point right there is negative 7. So f of 1 equals negative 7 because you take the y coordinate. Okay, we already know the x coordinate. We need to find the y coordinate. So f of 1 equals negative 7. Now let's go and find negative 2. So again, I'm going to draw a line through negative 2. Then I'm going to draw that circle right there, and I'm going to see, what is that y coordinate? That y coordinate is positive 2. So f of 1 equals negative 7, and f of negative 2 equals positive 2. So now, I'm just going to plug those in for those points right there. So that becomes negative 7 minus 2 over 1 minus negative 2. You can just simplify that down. When you subtract a negative, you add it. So that's negative 9 over 3, which is negative 3. Okay, so the average rate of change between those 2 points is negative 3. That means if we were to draw a line through this right here, pretend that's straight. If you were to draw a line through that right there, that slope would be negative 3. Okay? Let's look at B. So again, let's label A and B here. What's happening? Okay, A and B. So A is our first term, B is our second term. Now I need to find f of 4 and f of 0. So I'm going to draw a line through 4. When you draw this line through 4, 1, 2, 3, 4, it crosses right there at 2. Okay? And then we have to find 0. So again, we can draw a line through 0. See where it crosses? It's right there. And that point ends up being 1, 2, 3, 4, 5, 6. So negative 6. So f of 4 is 2, and f of 0 is negative 6. Now I can just plug those in, simplify this down, and you end up with 2. So the slope between 0 and 4, or the average rate of change between 0 and 4 is 2. And that's the secant line. Okay? We're going to not do B, D, or F, but let's do these ones. Okay, so we need to find the average rate of change given a function. It's not a graph, though. Now it's just our regular function. Okay, so it's between negative 1 and 2. So again, we're just going to use this same formula, or this same little thing. So A is your first term, B is your second term. So I need to find f of negative 1. So I'm just going to plug negative 1 in for my x's. Plug that into your calculator, you get negative 21. Now let's find f of 2. Plug that all in, and you get negative 6. Now we can just plug that into our equation. So we have f of 2 minus f of negative 1 all over 2 minus negative 1, which is really negative 6 minus negative 21 over 2 minus negative 1, which is negative 6 plus 21, yada, yada, yada. You end up with 5. So the average rate of change between negative 1 and 2 is 5. So that has a slope, that line, the secant line has a slope of 5. Okay, let's look at C. So f of 4, plug 4 in, and you'll get negative 3. Plug 7 in, and you get 183. Now let's just plug that into our formula. So f of 7 minus f of 4 all over 7 minus 4. If you simplify this down, just plug in those numbers for that. Keep simplifying, you get 62. So that's a big rate of change. Okay, that's a really, really steep slope. You wouldn't want to climb a mountain with a slope like that. Okay, now let's look at E real quick. So f of 2 equals negative 1. F of 8 equals 0.5. Now you can just plug that into here, simplify that all out, maybe, and you'll end up with 1/4. Okay, pretty simple, pretty straightforward. Now let's put this into context. So a company's total cost in dollars was given by this formula. So 0.05x squared plus 40x plus 100 or 1,200. We need to find the average rate of change of the total cost for the first 200 units. So that's going to be from 0 to 200, because if it's the first 200, we started at 0, we're ending at 200, right? So zeros are A, 200s are B. So let's find C of 200. Plug in 200, you get 11,200. Now we have to also find C of 0, you get 1,200. Now we're just going to plug it into our formula that we've been using this whole time. Okay, and then you just simplify this down, you end up with 50. Okay, sorry I keep saying K, I don't mean to do that. We are just going to skip this one for now, we'll save it for class, and I will see you guys tomorrow. Remember to take the quiz.